In this lesson, we'll talk about the second benefit of feature engineering, which is the ability to apply domain knowledge. This allows us to leverage insight into the problem to improve model performance. As usual, I recommend navigating to Data100 Data Hub so that you can follow along. In this case, our insight for the problem comes in the following form. In this particular case, our insight comes in the following form. We know we're trying to predict miles per gallon, and we also know that the displacement of an engine is defined as the product of the volume of each cylinder and the number of cylinders. However, not all cylinders fire at the same time, so the fuel economy might be closely related to the volume of any one cylinder. Knowing this domain knowledge, we can compute a new feature that encodes the volume per cylinder by taking the ratio of displacement and cylinders. Let's define a new feature function that computes this volume per cylinder. Once again, instantiate, fit, and predict using this brand new feature function. With this new model, let's evaluate and plot. And we've now got our new winner. We've got an MSE of 9.1, and we can see that this graph looks semi-reasonable. Our points are clustered around the line y is equal to x. Let's now apply the feature functions that we explored in the previous lesson. Do they work here? Let's attempt polynomial features. We'll define a new feature function that imputes data using the functions that we defined before in the last lesson. We'll also use the polynomial features that we defined in the lessons before it. Like before, we'll now featureize the data, fit a model, and predict with it. Finally, evaluate and plot. And again, we have a new best model. Here, our new best model achieves an error of 6.5. And our plot looks reasonable. So that seemed to work well. Let's try our sinusoidal features from before as well. Let's define another feature function that imputes data and applies the craziest of features that we saw in the previous lessons. Featureize the data, create a new model, fit the model, and predict with it. Finally, evaluate and plot. And there we go, again, our best model yet at 6.1 in error. However, you notice that between the last model and this one, the delta became a lot smaller. We went from 6.6 just to 6.1, just a reduction of 0.5 in absolute MSE. So that means we're getting some sort of diminishing returns. And unfortunately, this random hodgepodge of features is what we call feature soup. It's senseless feature mashing to get a better result. We'll see why this is bad specifically in future lectures, but for now, it looks like feature soup is getting diminishing returns and has plateaued in performance. We're hitting a wall here, so let's turn to an alternative. We'll leverage insights about the problem, our domain knowledge, to further significantly improve our model performance. We saw a little bit of this domain knowledge earlier, but we'll need a little bit more to boost the performance of this model even further. We'll see that in the next lesson.